Hi everyone, welcome. We are going to wait just another minute or two to allow any folks to join us here before we get our presentation started. In the meantime, if you wanted to use the chat window there to kind of introduce yourself, maybe talk a little bit about some of your current work that's going on, please feel free to do so. Again, we will kick off here in about 2 minutes. Okay, it looks like we've got a pretty good crowd today. Please feel free to kind of use that chat window as a back channel as we go along to share any questions or findings with others, including participants and our presenter. I will be sure to monitor that chat window to make sure that our presenter does address any questions that might come through in regard to his presentation today. With that, let's go ahead and get started. We want to welcome you all to another edition of the MVLRI Research Webinar Series. MVLRI is a division of MVU, or the Michigan Virtual University, a nonprofit organization whose mission is advancing K-12 education through digital learning, research, innovation, policy, and partnerships. MVU's efforts include providing online courses to K-12 students across Michigan and the United States, as well as providing a variety of professional learning opportunities for educators focused on innovative educational practices such as blended learning, and also providing resources, products, and services to personalize learning options for their students and improve student achievement. Just a quick disclaimer before we introduce today's presenters. We just wanted to make note that this webinar will be recorded and shared publicly. Consequently, anything shared during this webinar, including chat comments, could be shared publicly. This webinar may represent a presenter's or an attendee's personal views, opinions, conclusions, and other information which do not necessarily reflect those of MVU and or the Michigan Virtual Learning Research Institute and are not given nor endorsed by MVU/MVLRI unless otherwise specified. Today, we're going to be hearing from Dr. Chen-Si Lin, Assistant Professor of Educational Psychology and Special Education at Michigan State University. His primary research interest is emerging technologies in language education, especially new forms of social media. He investigates the process and outcome of social learning and authentic communications on a social network site developed for language learning. His secondary research interest is psychology of reading, particularly the reading development of Chinese language learners. He examines how first language and orthographic co-occurrence in second language affects the reading development of Chinese learners. Today we're going to be hearing about class size and teacher load effects on student learning outcomes in virtual courses. With that, I'm going to hand it over to our presenter, Dr. Chen-Si Lin.
Hi, good afternoon, everyone. Can you hear me okay? Type yes if you can. All right. Thank you for coming to the webinar. This is the first time I ever presented in a webinar, so I'm really excited about that. So today I'm going to share our current finding regarding class size. I worked on this project for a little bit over a year, and it's time to present some findings. So today I'm going to present the relationship between class size and the student learning outcome. In addition, I'm going to present our finding regarding teacher load. So here we are. So I will divide today's presentation into two parts. The first, I will talk about class size from the very beginning, why we care, and to the findings. And then I'll present teacher load from why we care and to the findings. I find it more organized in this way. So the fundamental question we need to ask ourselves is, why do we care about class size? On the one hand, I guess everybody agrees that small class size are perceived to be beneficial. If you have kids in schools, you probably want them to be in small class size because your kids may get more attention and get more interaction with other kids and the instructor. So it makes more sense to have small classes. On the other hand, having small classes has a cost. It greatly increases educational cost. And in addition, we just do not have enough qualified instructors around. So even if we have the money at our disposal, we just may not be able to afford a small class size because of the lack of qualified instructor. So this is the highlight from the literature in regard to the effect of small class size in traditional face-to-face settings in K-12. It's not surprising that students in small class size will get more individual attention from teachers. In addition, students in small class size are likely to have more frequent interaction with the instructor regarding the learning activities. With these two benefits, it is not surprising that small classes tend to lead to better grade. Students in small class size have about 0.1 or 0.2 effect size higher than students in large class size. In addition, small class size usually benefit minority students or underrepresented group better. Research shows that African American people gain more from small classes. So this is the goal to narrow the achievement gap. So the gain from small class size is not just temporary. Research also shows that it has some long-term lasting effect on college completion and salary. If you have small class size up to 8th grade, it can lead to increased college completion and higher salary in the future. So this is a powerful argument for reducing effect size, reducing small class. In fact, many states have some regulation on the cap of the class, but that's not the primary focus here. In addition to the benefit of small classes from student achievement, we also want to know teachers' opinion. In our group, I think a lot of you are teachers. I mean, teachers, especially K-12 teachers, just love small classes. In a recent survey, in a survey from 2007, it asked teachers about their preference regarding small class or increase of salary. To my surprise, 81% of teachers prefer a reduction of class size over an increase of salary. So, from teachers' perspective and student learning outcome, it's justified to have small classes in traditional K-12 settings. But the situation in online K-12 setting is quite different. This is a direct quote from Watson et al.'s Keeping Pace I know most of you are familiar with Keeping Pace. This is published in 2015. So it says schools' use of online learning is being driven primarily by the desire to offer courses that are otherwise unavailable or for which costs are difficult to justify given small class sizes. At this point, I want to stop for a second and want to ask you a question. What is the percentage of classes that is equal or less students in your school? You can give me a rough estimation, but I just want to get a sense the situation in your school. Yeah, in your department, in your school, less than 10 students. What's the percentage? Wow, 2 to 100, but what's the percentage of students? How many percent of the classes are less than 10 students? 8 to 12, 8 to 20, that's a good size. 10 to 15 per class, I think that's a really good size. Online here, yes. 8 to 12, that's also a good size for undergrad, right? Okay. Graduate student, okay. 70 in one class last semester, wow, that's huge. So let's look at the project I'm looking at. So from Watson's study, it seems small classes is a common situation in online K-12 courses. And this is the context I'm working on. So on average, the class size in traditional settings is 24 to 26. And apply to elementary, secondary, and high school. But in the setting I'm working on, you can see this is the accumulative percentage. You can see that the 47% of the classes have less than 10 students, equal or less than 10 students. You see, one student in a class, that's about 9%. 3 is about 15. And up to 10. So you see, this is a common situation in several statewide virtual school. This is the context I'm working on, the school I'm examining this class size. So I just want to give you a situation in one school. I want to give you a contrast. So if 40% of the classes have equal or less than 10 students, which is less than half of the average class size in traditional settings. But on the right end, you see some classes have 59, 60 students, but that only represents a small percentage of the classes. So you see the problem here. We want to give students the best education, but with less than 10 students, I doubt if this kind of model is sustainable. Yes, this is a self-paced course.
And Chenzi, I think we can just maybe clarify here. We had a question about the type of online course pedagogy. We're talking about, for the most part, I believe, supplemental courses taken by students in a supplemental context from a state virtual school. Is that right?
Yes. Can you clarify supplement?
Sure. So these students are taking maybe one or two online courses to supplement their actual their actual kind of normal face-to-face
That's right.
course load.
Yes, yes, exactly. Thank you for clarification.
Sure. And Ray, I was also asking about maybe some of the pedagogy within those courses. So are they synchronous or asynchronous? What sorts of learning content is involved? Are they video-based courses? Do they have instructors backing those courses? Is there kind of like one descriptor that describes all of these courses that you're studying here?
Okay, let me clarify. So I believe most of the courses and classes I'm examining are asynchronous. So only a few, probably less than 1% are synchronous, has synchronous component. Most of them are self-paced, synchronous, and video-based lecture, and some content are acquired from the publisher. So that's the basic context of this school I'm examining. So in this context, but still it's a little bit surprising to see 40% of the classes has less than 10 students. I'll continue,
Sure.
but you can ask any question in the chat and I will respond. Self-paced is different than the instructor. Yes. It's self-paced. Only probably less than 20 classes in the setting has instructor-led synchronous component. Other than that, it's all asynchronous. So Susan raised a really good question. This is not a class. Well, technically, we place them in a class session, but you are right. Maybe I need to justify why it's a class. I'll think about it. Yes, they interact in class one-to-one. No, I'm not sure how I equate self-paced instructor lead cohort asynchronous. Well, I'll continue to present, but you can type your questions below, and I will answer when I have a chance. So in online class size, there are some discussion around how to decide the size of online classes. And these studies are all done in higher education. So one study that used the time required for instructors to determine the online class size. So this study came up with 17 in traditional settings and 12 in online setting in higher education, based on 85% focus on teaching, 5% on research, 10% on service, and this is a 3-course assignment. Another perspective is from teacher perception. From another study, they examine teacher perceptions on different class size, and they came up with a different number. 22 is the average online undergrad courses, but they believe that if they have 15.9, they can give students highest level of interaction. The last is pedagogy. From pedagogical perspective, they come up with a 25 to 30 as the ideal number for online classes. But these studies have some limitations. First, it's based on perceptions, not effectiveness. It's based on teachers' perceptions and load. So we don't know if this actually affects students' learning. And the second is based on the data from undergrad courses and some higher education. We don't know if these rules apply to online classes. So in order to fill the gap and see if there's any relationship between online class size and the student learning outcome, I decided to fill the gap. So I examined these two research questions. First, what is the overall optimal class size across the subject? And the second, what are the optimal class size in each subject? So in the sample, we have 21,000 enrollment records from roughly 12,000 students in the from 2013 to 2014 school year in the Midwestern statewide virtual school. This is the data set, and here are three key measures. First is class size, and the second is number of courses taken in a single school year, which I'll explain later why it matters. And the third is subject. I divide the subject into 6 categories: English, foreign languages, science, math, social science, and others. And their learning is assessed is based on their final grade that they receive from these online courses. So the class size is the sum of the students who had completed regardless of their grades. Students who dropped the class were not included when calculating class size because they do not have final grade, which I cannot analyze it. And the second is we also talk about class size distribution. So 1 to 5 students is 29%, 6 to 10 students 18%, and 33% of the classes have more than 21 students. And again, this is self-paced learning. So the number of courses taken per student in this school, you can see one course is about 54, and 2 courses is about 34. So here I need to make a justification. So in the literature, it suggests that the student's online learning experience will affect their learning grade. For such reason, I only include student first enrollment record in the analysis because it could get an comparable learning outcomes. So in the data analysis, I apply for several exclusion criteria. First, we've talked about if they withdrew or dropped, I exclude them in the analysis. I only use the first record if students enroll in multiple courses because the literature suggests that the online learning experience may affect their learning outcome, which I want to control for. And the third is that I exclude classes with less than 10 students. The statistical analysis requires some variance within class. So if the class is only 1 or 2 students, there's not enough variance that can justify the statistical analysis I'm using. So I exclude a lot of classes with less than 10 students. And after applying for this exclusion criteria, it yields a final sample of 10,648 students from 744 classes in 6 subjects. So the analysis I use is called hierarchical linear modeling. Hierarchical linear modeling is the advanced statistical analysis that accounts for lack of independence within classes in this case. So in traditional regression, we assume that the students are independent from each other. But this is not the case if we look at the class size effect, because we believe class has some impact on students, so their performance are not totally independent. It may depend on the class or the instructor. So for this reason, I use hierarchical linear modeling to account for this variance. In this case, the level 1 is student enrollment record, and level 2 is each class session. So class 1 may have student ABC, and class 2 may student DEF. And I examine the model. I examine the relationship using multiple models. So the first model is unconditional model. The purpose of using unconditional model is to test the overall class effect. If there's enough variance in class, we know how much difference in class, which will warrant the next analysis. In model B, I add the class size, which aims to test if the relationship between class size and the student final grade is linear. Model C, in addition to the class size, I added class size quadratic term, which is to test if the relationship is parabolic. Model D, add the class size cubic term, which aims to test if the relations have two peaks or joules. I have a typo, sorry. So the model A, the result shows that 23% of the variance in their learning outcome can be attributed to differences between classes, which warrant our next analysis. Now we know there are some variance, there are some differences. We want to know how much variance that class size explains. So model B, here's the result. The x-axis is the enrollment per class, which is class size. The y-axis is their final grade. It ranges from 0 to 100, their grade. So as you can see, this is a linear relationship. As the class size increases, students' final grade also increases. This is very interesting because if this is the case, it gives the school a justification that it can increase the class size. But we only get most 60 students here. We don't know what will happen once we beyond the point of 60. So that's a linear relationship. But this, if we see this picture, it may make sense to school because it gives them a justification to increase class size. But from a common sense, we can endlessly increase the class size because it will affect student outcome to some extent. And the next analysis, I want to examine if the relationship is actually linear. I want to see if adding a quadratic term depict the relationship differently. So in this model, I add a quadratic term which shows the relationship between class size and student learning outcome is not linear. If we have small classes, like from 10, as we increase the class size, we see the increase in student learning outcome as well. But you see the peak is around 45. Once we beyond this point, if we increase class size, the learning outcomes start to decrease. And you see, if we have a class size of 60, the learning outcome is roughly the same as we have probably 20-something students. So that is the quadratic parabolic model. In the next model, I want to further test if this is the model that can clearly depict the relationship. So I add a cubic term. But The cubic term does not add any significance. It suggests no two peaks or drops. So we still believe that model C is depict the clear relationship, the nonlinear relationship between class size and grade. The last attempt is to do a fractional polynomial analysis. For this analysis, in the previous analysis I've done, I used a set power, it's power 1, 2, 3. For fractional polynomial analysis, they have freedom of choosing a power from -3 to +3. So, in other words, it allows to capture the relationship in a more smooth curved lines. So here is the result. You can see the fitting line is all smoother, and you see we still have a peak around 45. So that's a finding across the subject. Next, I want to move that into different subjects. I apply this fractional polynomial analysis in each subject. Since it fits the best across the subject, I use that, apply that into different subjects, which yield a little bit different findings. So here is the finding in English classes. You can see there are some decrease if we increase class size from 10 to probably 12, but it gradually increase as we increase the class size. But this relationship was not significant for English courses. In the next slide, the foreign language, we see a sharp increase here at the beginning. If we increase class size from 10 to probably 12, 13, and we see a steady, flat, or toward the downward trend. But this relationship was not significant either. I can understand this part because I was a foreign language instructor before, so I understand this part. If the class was too small, some activities, some foreign language practice may not be easy to conduct. I'm not sure about the online situation, but at least that's what happened in face-to-face situation. So I can understand this part, but this part probably makes sense, but it was not significant. So for English and the foreign language class, the class size effect was not significant. Here comes the science class. Science class, the pattern is very much similar to the overall relationship between class size and the final grade. We see that it's a parabolic shape with a peak at 35 instead of 45 across the subject, which means probably science class is more difficult than other subjects, and it's justified with more small class. Teacher probably need to spend more time with answering student questions, so the class size matters, and it needs to have small classes. This is a good question. Student-teacher ratio as a factor. I am not sure how this is different from the class size. Since class size captures the number of students in that, I don't know how it's different. For math classes, the relationship was similar to science, but with a peak around probably 35 to 38 at this point. So this is for math. It's a little bit lower than the general class size effect, which suggests that the math may be a little bit difficult. Just like science, it requires more teacher attention. Social science is a different story. The shape is similar, but you see the peak point shifted from 35 in math and science to 45-ish in social science. So social science teachers may be able to handle large classes. In other subjects, the peak point should back to 35. So here are the quick summary. I try to do that so that you don't forget about the findings here. So I put English, foreign language, science, math, social science, other subject. We look at it at all and see. So the asterisk at the beginning indicate whether the relationship between class size and final grade is significant or not. So in this case, these four are significant, and these two, English and foreign language, are not. So science has a peak at 35, math is 35-ish, social science is 45, and other subjects 35. So you get a rough idea how class size affects students' learning. Yes, I believe that the difficulty level may play a role in this analysis, which I'm going to talk about. So I want to talk about the implication of this. So the context matters. I don't know in what way, but the context, as we discussed earlier, is a self-paced learning. There are some peer-to-peer interaction, but I don't know how much the peer interaction is. But I'm sure there are a lot of teacher and students interaction. I wonder the difference in this one may be attributed to the interaction or the difficulty of the course. Maybe in English and foreign language, it's not significant, probably due to the maximum class size. So English is only 40 and foreign language is 50. Maybe we haven't reached the turning point to see a trend. In math, science, and subject, it probably is more difficult, so the teacher can only handle 35, but for social science, they can handle a bit more. But for English and foreign language, I don't want to say it doesn't matter, but we probably do not get a large enough class size to make it matter. That's the bottom line. So this finding is quite different from traditional K-12 setting, because on the one hand, we find that class size reduction helps if the class size is very large on the right side. But online classes may need the minimum number of students to be effective. So it also helps to address that why traditional face-to-face setting find different results. Though most of the studies find that the reduction of class size is beneficial, but some find it's not. So this may help to disentangle the mixed results in the literature. Maybe they just model the relation in a linear way so that they fail to consider the relation may not be linear, or the setting. Yes, I'm looking at the session size, which I call it class. So there are some limitations before. So the class size only explains very small amount of variance between classes. The huge part is still unknown. As Susan in the chat box suggests, we may consider other subjects. From my personal experience, self-regulated learning may play a role in this one. So this study does not account for individual difference. We do not have students' survey responses or whatsoever. So we do not have such information to further partial out other variants. And this is only limited to one context, self-paced learning in one virtual school. And the next one, we know that session size, class size matters, but one question we still don't know is how many students the teacher can handle across sessions. What's the overall optimal load for teachers across? Then the first question I look at across the subject, and the second look at in each subject. So I apply very similar analysis. Teacher is level 2 and student is level 1. Oh, no, I put that the wrong order. Level 1 students, level 2 is teachers. Use the H1M, and here's the result. This is a bit difficult to explain, so I have to use table to help me. So bear with me if you are not a stats person. Let me walk you through. In model 1 is the unconditional model, which warrant, I do not have the number on top of my head, but there are differences between teachers. And the level 2, this is interesting. I added spring semester, summer semester with a reference category the fall semester. You see, spring semester has a negative effect, summer semester has a positive effect. This is still very mysterious to me. In the third analysis, I added the teacher load. I added number of courses. Because number of courses matters, we see that the number of courses has a negative effect on their final grade. So if the teacher takes one more course, on average, his or her student will have 1.03 grades less from this model. In model 4, I added teacher load. You see, teacher load is positive, whereas number of courses is negative. Let's pause here for a second and digest the information. This means that if teachers do not get additional courses, having more students may be a good thing. But if you increase the course, you need to have 30-something students in this load to offset the negative effect from this one. So the course is across sections, and teacher load is the number of courses is the subject title, I believe. The teacher load is number of students the teacher has across sessions. So Joe's question changing courses equal all sessions of Algebra 1. Yes. Yes. Courses is the same title. So they may have Algebra 1 but 3 sessions. So that accounts for one course. So the number of courses basically indicate how many preparation they need to do. If the same subject title, like Algebra 1, they only need to prepare once. Thank you for the question. Yes. So the third part of analysis is classes, which class sessions. And here is number of courses. It's the measure of the preparation that teacher requires. So as you see, if you increase the number of courses, a student need to prepare more, that definitely will have a negative effect. So teacher load in each subject yield mixed results. This is a bit frustrating for me because I like to see pattern, but we don't see it. But next slide, we'll have a result from class size and teacher load, which shows more information. So we find that the teacher load has a positive impact for English and social science, but negative effect for math, and no significant impact for foreign language, science, and other subjects. So now we put everything together from class. We can skip that given the time limit, but we can put this together. So for English, the class size is not significant, but teacher load is significant, which means English teachers can teach more students and class size does not matter. For foreign language, neither class size nor teacher load matters at this point, given the class size we have or the teacher load we have. For science, we know the peak of class size is 35, but teacher load does not matter. For math, it's different. Teacher load matters, and we have a peak at 35. It indicates that the teacher preparation, math teachers' preparation affects students' learning outcome. So don't give math teachers too much preparation, focusing on small math classes because it requires a lot of time for preparation. For social science, it's a very interesting result because the class size is larger than the others and the teacher load is positive. So teachers can hold more students and they can hold a larger class size. For other subjects, class size does not. For other subjects, class size has a peak at 35, but teacher load in general does not matter. So here is the results from both class size and the teacher load. Though this is two different analyses, but I believe that looking at the result in parallel give us some additional information how to make informed decision regarding class size in online settings. So that's the end of my presentation. Sorry to go a little bit more than 45 minutes I'm given, but here are the results. I'm happy to answer any question you may have or to seek any collaboration if you are working in online settings. Yeah, Susan, thank you for your feedback. I think, yes, I shouldn't use does not matter. Yes, matter less, or it doesn't show a significant impact at this point. True. I know ELL and special education students may need additional attention, but unfortunately, we do not have such information in student enrollment record. I would love to look into that, but I don't have such information. The pedagogy used before the details. The pedagogy, I have very limited information regarding the pedagogy, to be honest. I only know that most of the courses are self-paced, video-based lecture, and a lot of materials are based on publishers on the content produced by the publisher. So the instructors, yes, digital tech, the instructors, most of them have very limited freedom to change the course content. In terms of Susan's question, I don't advanced class can have more students. I don't know, because it requires additional effort to tag each classes and understand the difficulty level. I may need further detail to look into that. I have the information, but I haven't had a chance to look at the difficulty level and how it affects the results. Thank you, Ray, for your feedback. Let's see, maybe important like the English math distinction. Susan, can you elaborate on the English math distinction? I am not following that part. Interesting. Thank you for sharing your findings, Susan. Yes, it's a hypothesis for additional tests. And this is only a finding from a single context. Maybe this finding will be different in another online setting. So if any of you have access to this kind of data, I'd be happy to talk to you.
And see, just before we wrap up, as a I guess just would you be interested in sharing your contact information, maybe your email address in the chat window, or any other way to keep in
Sure.
touch with you if folks have additional questions about the research or maybe want to collaborate on some further research?
That's my email. I agree with Susan. It's very difficult to find such a wide range in one school. And this is personally, I think this is a valuable information, because in traditional settings, we find the effect reducing class size from 23 to 18. But in such a wide range, it allows us to model the different relationship. Yes, good for stats, but it also creates a lot of huge standard errors.
And Shinsi, maybe we should also mention too that this research, I guess, will be submitted to a peer-reviewed journal soon. Is that correct?
Yes. Yes, I'll definitely give more context. Yes, pedagogy.
Okay, well, again, we're going to go ahead and wrap up here. Again, if you have any further comments or questions for Chincy, please feel free to use the chat window. Again, we want to give Chincy a big round of applause and a thank you for joining us today and sharing his research. Very informative work, and we'll be happy to see what the implications of this work are going forward. We do want to mention just a couple of kind of parallel projects that the Institute engages in. We have a Virtual Viewpoints podcast series where we talk to folks throughout the United States doing work in blended and online learning and kind of talk to them about how they're implementing their own research or external research into their own work. So feel free to check out our podcast series. You can download that in the iTunes Store, the Google Play Store, or listen on our SoundCloud channel. We also have our guest blogger program where we invite folks to come on and maybe share some preliminary findings from their own research or just talk about some of their own work in their own settings and context. So if you'd like to learn more about how you might be able to blog for us on our blog platform, check out that link there to learn more. And then in the meantime, feel free to keep in touch with us over email at mvlri@mivu.org. You can feel free to offer any suggestions or feedback for us on our webinar series or any of our other projects. You can sign up for our mailing list to get notified of future webinars and other projects and reports that we release. We have our Facebook and Twitter and LinkedIn handles listed as well. So if you'd like to follow us on social media, you can do so. Also check out our YouTube page where we host all the recordings of our webinars, and you can expect to see the recording of this webinar to be posted within the next 24 hours or so on that YouTube page. In terms of upcoming webinars, you can check out our website, mvlri.org, and then under presentations and webinars, you can see what we've got upcoming, as well as links to all of our archived webinars with the recording links included. With that, we just want to wish everyone a happy rest of your Wednesday. Thank you so much for joining us, and take care.